So hello everyone, welcome back to the PYQ series of CSIR NET. So the question is, consider the following sequence of rational numbers where QK is defined like this, and they're asking that which of the following is yeah are true. So what we have here is QK equals to sigma n equals to 1 to k 1 upon 10 to the power n square. Okay, so Q1 would be what basically 0.1, and then Q2 would be 0.1 plus 0.0001, which will be 0.1001, and Q3 would be what? 0.1 plus 0.0001 plus 0.00000001. So it would be 0.1001 000. What is all four fractions now? Okay, so the terms of Q and QK sequence would be like this only. So the first question is QK bounded? This is easy, no, because we can see that each QK would be less than 1. No, because यहाँ पे हम बस 10 से डिवाइड ही करें तो वो कभी भी 1 से एक्सीड नहीं कर पाएगा. And all QK would be greater than 1, greater than 0. वो भी श्योर है Q1 0.1 है, एंड देन Q2 में Q1 कुछ ऐड कर रहे हैं तो वो भी 0 पॉइंट मतलब 0 से बड़ा ही रहेगा. सो QK is less than 1 and greater than 0 for every K belongs to N. Or so this would imply QK is bounded. Even we can calculate a much good lower bound of QK, upper bound of QK means less than 1, we can also find that easily. So QK is bounded, so that means this option is automatically cancelled, is automatically wrong. Okay, so we are left with the convergence and Cauchy's. So just to recall, what are Cauchy sequences? So this in layman terms, or means whenever we have a sequence, like suppose AN is a given sequence, okay? So the terms will be A1, A2, A3, and so on. So we say that AN is Cauchy sequence if, like, for every epsilon greater than 0, there exists a natural number n such that for all n comma m greater than equal to n, an minus am is less than epsilon. What does it mean? Like, after a certain term, the difference of any two terms is always less than epsilon. Means we can find any two terms, means we can say that the terms get arbitrarily close to each other after a certain term. Okay, maybe A1 is like this, A2 is like this, and then A3 is somewhat like this on the real line. And then after A3, A4 is a bit closer to A3, and then after some terms, all the terms are in some are close to each other. Any two terms will be close to, means the distance between any two terms would be close to would be very small. Means we can make the distance of the terms smaller after a certain finite terms. Certain finite terms. After those terms, the distance between any two terms we can make as much small as we want, because it is for every epsilon greater than 0. Okay, so this is what Cauchy sequence is. But in the question we have QK equals to n equals to 1 to k 1 upon 10 to the power n square. Okay, so what we are doing, so we are taking two terms, Qn and Qm, two terms of the sequence Qk, and let n is greater than m. So we can calculate Qn minus Qm, and this would be what? See, Qn is greater than m. So when we subtract Qn minus Qm, so Qn में क्या आएगा? 1 upon 10 to the power plus 1 upon and up to so on, where 10 to the power n square minus 1 upon 10 plus up to where 1 upon 10 to the power m square. So m would be somewhere near here. So these terms would get cancelled, and we will get eventually what? We will get mod of 1 upon 10 to the power m plus 1 whole square. After m, 1 upon 10 to the power m plus 2 whole square, and so on up to 1 upon 10 to the power n square. Okay, so what is 1 upon 10 to the power m plus 1 square? What it is? It is 0.000, and 1 would appear at this position would be what? M plus 1 position. No, means 0.000, and 1 would appear at m plus 1 position. And if I ask you what is 10 to the power m square, this would be 0.000, and 1 would appear at mth position, and mth is certainly uh, is what is before m plus 1. So 1 by 10 to the power m square is greater than 1 upon 10 to the power m plus 1 square, naturally. And what we are doing, and we can also see that these all terms can't even these all terms are smaller than 1 by 10 to the power m square. How? Because see, this is smaller than 1 upon 10 to the power m square, and then this is again after 1 m plus 1 m plus 1 square, means 1 will appear after this term. No, and we are just adding, but these won't get big from 1 by 10 to the power m square. So this would be less than 1 by 10 by m square. And now we can make use of what? We have to make sure that these, we can use Archimedean property to make sure that these is less than whatever epsilon we choose. So we can use Archimedean property here. Like what is the Archimedean property? That for every epsilon greater than 0, there exists some number, say n naught, such that for every n greater than or equal to n naught, 1 by n is less than epsilon. This is the Archimedean property. Okay, so, and these are all natural numbers, and 10 to the power m square is again a natural number. So we can find what? So we can choose n naught such that, or we can choose some number, choose n such that 1 upon 10 to the power n square is less than epsilon. And then when we will choose m greater than n, 1 upon 10 to the power m square would always be less than 1 by 10 to the power n square, and this is an epsilon. How we are guaranteeing that this term is less than epsilon? Because of the Archimedean property. Okay, अगर 1 by n छोटा आ रहा है, तो अगर हम 1 upon 10 to the power n square, तो वो भी छोटा ही आएगा. Don't get confused है, वहां पे हमने 1 by n लिया, यहाँ पे हम 1 by 10 to the power n square की बात कर रहे हैं. जब 1 by n छोटा है, तो 1 upon 10 to the power n square तो ऑटोमेटिकली छोटा हो जाएगा epsilon से. Okay, so what we have proved that for every n comma m greater than or equal to n, Qn minus Qm is less than epsilon, and this is what a Cauchy sequence does. So this implies Qk is Cauchy sequence. And we know that a Cauchy sequence in R converges in R. Okay, but the question isn't asking about R. The question is asking about whether the sequence converges in Q or not. So the question is, uh, this sequence is bounded and convergent in Q, they're asking. So we can say that we are not if the sequence wasn't, if they're asking about R, then the a Cauchy sequence in R is implies convergence in R. But will it be convergent in Q? So we can see that what QK is. QK is actually 1 upon n equals to 1 to k, 1 upon 10 to the power k square. So if we take out the limit, we know that this is convergent for sure because it is Cauchy in R, so it will be convergent in R. We know that it is convergent in R, means the limit exists. So what will limit QK? Limit k tends to infinity would be summation n equals to 1 to infinity 1 by 10 upon n square. That is a limit. So it would be what? 0.1001 and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then these one are appearing at what? 1, 4, 9, 16, and so on positions. So, and we are going to infinity. So these are first of all non-terminating and also what? Non-repeating. Whatever the number would be there, it would be non-terminating because it is going to infinity, and it is also non-repeating because one are appearing at always near position, not the because they aren't repeating, so it is not repeating as well. So this implies limit qk k tends to infinity does not belongs to rationals. So this implies what? Bounded and Cauchy, but not convergent in Q. So option D would be correct. This is wrong, and this is also wrong because it is a Cauchy sequence. So D is the correct answer. Thank you.